Good morning dear students, this is Bonani Porokasto. I welcome you all to today's video. Here we are doing the chapter Continuity and Differentiability. Now we will find the derivatives of some inverse trigonometric function. So here example 26 is given fx equal to sin inverse x. Now we have to find f dash x, that means we have to find derivative of sin inverse x with respect to x. So let us assume that y is equal to sin inverse x. Here the important point is sin inverse x is not equal to sin x whole inverse. Sin x whole inverse is equal to 1 by sin x. But we cannot write sin inverse x equal to this 1 by sin x. Now we will write sin y is equal to sin inverse x. So from here we will get sin y is equal to x. Now we will write d dx of x is equal to d dx of sin y. Here we are differentiating both the sides with respect to x. So d dx of x is 1 and d dx of sin y will be cos y dy by dx. From here we can find dy by dx is equal to 1 by cos y. So our question was fx is equal to sin inverse x and we have assumed sin inverse x is equal to y. So whenever we will find f dash x, that means we are finding d dx of fx. Since we have written here fx is equal to y, so d dx of fx can be written as d dx of y. That means we have to find dy by dx. So here it is dy by dx is equal to 1 by cos y. Now we will simplify this. We can write cos square y is equal to 1 minus sin square y from the formula sin square y plus cos square y is equal to 1. Now in place of sin y we can put x, because here we have written y is equal to sin inverse x, so sin y is equal to x. So from here we can write in place of sin y x. Now cos y will be equal to root over 1 minus x square. So here in place of cos y we can write root over 1 minus x square. So dy by dx will be equal to 1 by root over 1 minus x square. So from here we can say d dx of sin inverse x is equal to 1 by root over 1 minus x square. Example 27, here we will find the derivative of tan inverse x with respect to x. So let us assume that y is equal to tan inverse x. Here we will find dy by dx. So from here we can say tan y is equal to x. Now d dx of tan y is equal to d dx of x. So from here d dx of tan y will be equal to sec square y and we have to write dy by dx, and from here we will get 1. So dy by dx is equal to 1 by sec square y. Now we know sec square y minus tan square y is equal to 1. So from here we can write sec square y is equal to tan square y plus 1. So in place of sec square y we have written 1 plus tan square y. Now since here tan y is equal to x, so in place of tan y we can write x. So our answer is 1 by 1 plus x square. So derivative of tan inverse x with respect to x is 1 by 1 plus x square. To do the questions of derivative using some trigonometric functions, these formulas are very important. Sin 2x is equal to 2 sin x cos x 2 tan x by 1 plus tan square x. Whenever we need sin 2x in terms of tan, we will use this formula. Cos 2x is equal to cos square x minus sin square x 1 minus 2 sin square x. So whenever we need cos 2x in terms of sin, we will use this. Cos 2x is equal to 2 cos square x minus 1. So whenever we need cos 2x in terms of cos, we will use this. and cos 2x is equal to 1 minus tan square x by 1 plus tan square x. So, whenever we need these in terms of tan, we will use this formula. Tan 2x is equal to 2 tan x by 1 minus tan square x. Question number 9 of exercise 5.3. Here y is equal to sin inverse 2x by 1 plus x square. Here we have to find dy by dx. To do this kind of questions, first of all we will cancel out sin inverse. So, to cancel out sin inverse, we need sin inside the bracket. To get sin inside the bracket, we will assume that x is equal to tan theta. Whenever we will put tan theta in place of x, we will get 2 tan theta by 1 plus tan square theta, which is equal to sin 2 theta. So, to do that, first of all we will assume x is equal to tan theta. So, from here we can say theta is equal to tan inverse x. Now, in place of x we have to write tan theta. So, from here we will get sin 2 theta. Now, we can cancel out sin. From here we will get 2 theta. In place of theta, now we will put tan inverse x. Now, we know the formula of d dx of tan inverse x. So, d dx of y is equal to d dx of 2 tan inverse x. So, here we can use the formula of u and v. Whenever 2 is constant, we have to find the derivative of tan inverse x. So, the derivative of tan inverse x is 1 by 1 plus x square. So, from here we will get our answer 2 by 1 plus x square. So, to simplify this kind of questions, we have to use trigonometric functions. Since here we have used x is equal to tan theta. Question number 11. Question number 11 is given y is equal to cos inverse 1 minus x square by 1 plus x square, and question number 12 is given y is equal to sin inverse 1 minus x square by 1 plus x square. See, in both the questions the only difference is question number 11 is of cos inverse and question number 12 is of sin inverse. So, first of all we will solve question number 11. Here again we will consider x is equal to tan theta. So, whenever we will write tan theta in place of x, we will get the formula of cos 2 theta. So, from here we will get 2 tan inverse x. Derivative of tan inverse x is 1 by 1 plus x square. So, dy by dx is equal to 2 by 1 plus x square. Now, to solve question number 12, here also we will consider x is equal to tan theta. So, we will get sin inverse cos 2 theta. Now, we cannot cancel out sin inverse from here because inside the bracket we have cos, we do not have sin. So, we cannot cancel out sin inverse from this step. So, we have to convert cos 2 theta in terms of sin. So, here we have written sin pi by 2 minus 2 theta. Now, see, whenever we will write pi by 2, that means this is the odd multiple of 90 degrees. Whenever it is odd multiple of 90 degrees, sin will be changed to cos. Now, whenever it is pi by 2 minus 2 theta, so it will be in the first quadrant. So, it will be positive. So, from here we will get cos 2 theta. So, to cancel out sin, we will write cos 2 theta in this way. So, from this step we can write pi by 2 minus 2 theta. Now, we will replace theta by tan inverse x. Now, we can differentiate dy by dx is equal to d dx of pi by 2, which is equal to 0 because pi by 2 is a constant, minus d dx of 2 tan inverse x. So, d dx of tan inverse x is 1 by 1 plus x square. So, from here we will get our answer minus 2 by 1 plus x square. Question number 14, here it is given that y is equal to sin inverse 2x root over 1 minus x square. So, here to cancel out sin inverse, we need sin inside the bracket. So for that we will assume x is equal to sin theta. Here we can also assume x is equal to cos theta. In both the ways we can solve the question. So see, our question is given sin inverse 2x root over 1 minus x square. Now see, if we put sin theta in place of x, so it will become 2 sin theta, and from here 1 minus sin square theta is equal to cos square theta. Root over cos square theta is cos theta. So from here we can get sin 2 theta. So whenever we will write sin 2 theta, we can cancel out sin inverse from outside. We can do the question by assuming x is equal to cos theta also. Here we have done the calculation. So from here we will get y is equal to 2 theta. In place of theta we can put sin inverse x. And we know the derivative of sin inverse x with respect to x. So dy by dx is equal to 2 into 1 by root over 1 minus x square. Question number 15. Here the question is given y is equal to sec inverse 1 by 2x square minus 1. So outside the bracket we have sec inverse. So we need sec inside the bracket so that we can cancel out sec inverse. To get sec inside the bracket we need cos in this part. So to get cos in this part we will use the formula of cos 2 theta. So for that we have to assume x is equal to cos theta. Whenever we will assume x is equal to cos theta, we can replace x by cos theta. So it will become 1 by 2 cos square theta minus 1. And we know 2 cos square theta minus 1 is cos 2 theta. Now from here we can write sec inverse sec 2 theta. Now we can cancel out sec. So after doing this we will get y is equal to 2 theta. Now we can replace theta by cos inverse x. Now we know the derivative of cos inverse x. The derivative of cos inverse x with respect to x is minus 1 by root over 1 minus x square. So here our answer is minus 2 by root over 1 minus x square.